Okay, welcome to 5.4 phase diagram. Okay, now let's look at what is the meaning of phase. Phase means that a homogeneous part of a system which is separated from the other parts by a distinct boundary. Then a component is the chemical species of a phase that can exist independently. Okay, now let us look at oil and water. Okay, oil and water, they have distinct boundary, they do not mix. Okay, so we have two phase here, and then we have chemical species that is oil and water that can exist independently. So we have two. Okay, then for example, another one, gas. Okay, gas, oxygen gas and neon gas, they are the same. There are no distinct boundary, so only one phase, but there are two components. Let's look at another one, ice. Okay, we have solid and liquid. Okay, they have distinct boundary, but they come from the same component, that is only water. Okay, then soft drinks, we have three phase, that is liquid, gas, and then oil here. Okay, soft drinks and oil. Okay, now let's look at what is the meaning of phase, triple point, and critical point. Okay, phase we have covered already. So what is triple point? Triple point is at temperature and pressure, all three phases, solid, liquid, gas, are in equilibrium with each other. Okay, critical point is at temperature and pressure above which is impossible to liquefy a gas. However great the pressure applied, liquid and gas phases is indistinguishable. Okay, later we will look at the phase diagram. Okay, now let's look at this. Okay, so this is the phase diagram where this axis represents pressure and axis X represents temperature. Okay, then just now we said we have phase diagram, distinguishable boundary. So we have solid, liquid, and gas. Okay, so for example, if I want to know a particular pressure and temperature, for example, okay, for example, this one is 100 degrees Celsius, and then this is, for example, 180 M. So at 180 M, 100 degrees Celsius, it would appear as liquid and gas in equilibrium. So you can see here a phase diagram is an experimental plot of pressure versus temperature which describe phase or state a substance can have and which equilibrium exists at particular pressure and temperature. Okay, so at this point, okay, you can see it is on the line. Okay, so we say that it's in equilibrium, or else if I put it here, okay, let's say 200 degrees Celsius, still 180 M, it exists as gas. Okay, so from the phase diagram here, we can know whether it is solid, liquid, or gas. Now, next one is the critical point. Okay, so critical point is C here, okay, where it is indistinguishable between liquid and gas phase. Okay, now next one is the triple point. Triple point is temperature and pressure where solid, liquid, gas exist in equilibrium. Okay, so this one, X is the triple point. Okay, then you can see here, if solid to liquid melting, liquid to solid freezing, liquid to gas vaporization, gas to liquid condensation. So from here we also know that solid to gas sublimation, gas to solid deposition. Okay, so this is what you need to draw in a phase diagram. Okay, for example, okay, if I will draw something like a Y. Okay, something like Y, but a little bit curved, this part. Okay, so what do I need to label next? I need to label triple point, okay, the equilibrium between solid, liquid, and gas. Another point that I need to label, that is the critical point. Okay, so now let us look at the information given here. Okay, this one is AO, B, and C. Okay, so line AO, variation of sublimation temperature with pressure. At any point of this curve, solid is in equilibrium with gas. Okay, if let's say I ask for what does this point represent, it means that solid and gas is in equilibrium. It is not solely gas or solely solid. Okay, if OB, it means that it is solid and liquid in equilibrium. If it's OC, it is liquid and gas in equilibrium. Okay, another one that you need to know is how to sketch the phase diagram of water and carbon dioxide. Okay, now let's see. Okay, something that which is important that you must know how to sketch for water and carbon dioxide is, okay, first make sure you label the axis. Okay, next you need to know for water 1 atm, okay, is above the triple point. Okay, whereas one for carbon dioxide, the 1 atm is below triple point. Okay, so these two you have to be very careful. Remember again, 1 atm is above triple point for water. Then for carbon dioxide, the triple point is above 1 atm. Okay, why is it important? What is the difference here? Okay, for example, 1 atm is like in at room temperature. Okay, we have 1 atm. Room temperature is 1 atm. So at 1 atm, okay, let's look at 100 degrees Celsius. So at 1 atm, this is the point. So meaning that it is liquid and gas in equilibrium. At this point, liquid to gas means that it is boiling. Okay, boiling process occurs. Okay, however, for carbon dioxide, we can see that the triple point is above 1 atm. So what is the meaning here? So means at room temperature, not even room, okay, let's not look at room temperature first. Negative 77 degrees Celsius, okay, it will become solid to gas. It doesn't undergoes the phase changes from solid to liquid. Instead, it's straight away solid to gas. So that you can see in the room temperature. Okay, for example, room temperature is 31 degrees Celsius. So when you put the dry ice in the room temperature, you can see that it straight away become gas, but not liquid. Okay, so another thing that you need to differentiate between water and carbon dioxide is the positive slope and the negative slope. Okay, for water, it is negative slope. For carbon dioxide, it is positive slope. Okay, now later it will be explained why water has negative slope but carbon dioxide has positive slope. Okay, so compare the phase diagram of H2O with carbon dioxide and explain the anomalous behavior of water. Okay, now let's look at it. Explain why solid liquid equilibrium curve OB has a negative slope or slant to the left. Okay, the answer given is because ice is less dense than water. The melting point of ice decreases when pressure increases. That is why this part from solid to liquid, it is negative slope. Okay, now next one is carbon dioxide. Okay, carbon dioxide, the solid is denser than the liquid. Melting point of the ice increases when pressure increases. Therefore, this part we have positive slope. Okay, now look at this. It is impossible for carbon dioxide to melt at 1 atm because the triple point of carbon dioxide is above 1 atm. So this one you must remember, the triple point for carbon dioxide is above 1 atm. Okay, now anomalous behavior of water. Okay, so just remember the density of ice is less than water. Okay, so this part explains all the anomalous behavior of the water because of one important thing, open structure. Okay, now let's look at how we describe the changes in phase with respect to the temperature at constant pressure or pressure at constant temperature. Okay, look at what does it mean. Okay, now let's look at this. Okay, this one is constant pressure. Okay, constant pressure but different temperature. Okay, so when it is X, okay, so I will label this as solid, liquid, gas. So X is solid, Q is overlapping on the line OB, so it is solid and liquid in equilibrium. Okay, R is liquid, S again overlapping on the line OC, so it is liquid and gas in equilibrium. Last V is gas only. Okay. Now next one. Okay, just now we have constant pressure, now we have constant temperature. Okay, again, label first, solid, liquid, gas. So Y is gas, K is liquid and gas in equilibrium, then L is only liquid. Okay, now let's look at one exercise. Identify the triple point and critical point. So our triple point is S. Okay, S is the triple point. Critical point is R. Okay, state the curve that represents equilibrium between liquid and gas. So label again, solid, liquid, gas. Okay, so the liquid and gas is SR. This line, SR. State the phase changes EFG when a sample is compressed at constant pressure. Constant pressure, we also call it as isobaric. Okay, so E is, we know that E is solid, F is solid and liquid in equilibrium, and then we have G. G is liquid and gas in equilibrium. Okay, another one is constant temperature. We call it as isothermal as well. So N is gas, M is gas and liquid in equilibrium, L is only liquid. Okay, so remember for phase diagram, you need to remember to label the critical point, triple point, and also label 1 ATM. Remember to label the axis for both, and then remember the shape is almost like a Y, okay? Then you must remember, is it positive slope or negative slope? Positive slope for carbon dioxide or solid that sink, negative slope for water, which it floats, okay, because of the density. Okay, so let's look at the phase diagram again for water and carbon dioxide. Okay, so remember one more thing. 1 atm you must label, but remember water, the triple point is below 1 atm, and then for carbon dioxide it is below 1 atm. So remember, you can use the phase diagram to determine whether which phase it is the compound is at certain pressure and temperature. Another one can find the equilibrium. Okay, so that's all for phase diagram.